Hi everyone. This time, two-step questions involving pH, pOH, hydronium, and hydroxide. The first question, determine the hydronium ion concentration if the pOH equals 12.82. First thing is, I'm able to identify that this is not a simple one-step question because it's what I call there is not a match. It's H3O plus and pOH. H3O plus goes together with pH, and this is pOH. So my first step is to convert the pOH into pH. The pH is going to equal 14 subtract the pOH, which here is 14 subtract 12.82. I can take my time. I can maybe do that in my head, but I'm going to calculate it. 14 subtract 12.82. 1.18. Once we have the pH, we can move forward to find the hydronium ion concentration because the hydronium ion concentration is equal to 10 to the power of the negative pH. And now I have the pH. So I'm just going to substitute that in. 10 to the power of negative 1.18. When I do this calculation, 10 to the power of negative 1.18, okay, 0.066069345. Our raw answer. When you go back to the question, we notice that the value given just had two significant digits. So we want our final answer to also have two significant digits, which this is the concentration where we're using our traditional significant digit rules, 0.066. And this is the concentration that we solved for, moles per liter. This is just a small extension from our one-step style of questions. I was able to identify that this was not a one-step question because what we were being asked for and what we were given didn't match. Second example, calculate the pH if the hydroxide ion concentration is equal to 1.56 times 10 to the power of negative 9 moles per liter. Again, it's not a match. pH, OH, that's not the same. It's not a match, which implies I have this extra step to think about. From the hydroxide ions, I only have one move, and that's to solve for the pOH. The pOH is equal to the negative log of the hydroxide ion concentration, which I'm just going to substitute in from the question, which is equal to the negative log of 1.56 times 10 to the power of negative 9 moles per liter. I type that into my calculator, the negative log 1.56 negative 9 is equal to 8.806875402. I want to avoid rounding at this point. I want to save any rounding until I reach the very end of the question. I have the pOH now. I need to convert that into pH. The pH is equal to 14 subtract the pOH, which here is 14 subtract this answer. This number is still just sitting here on my calculator screen, so I'm going to type in 14 subtract that answer. And I arrive at 5.193124598. I found the pH, but this is the raw answer. I need to go back to the question, think about the significant digits. 1.56 times 10 to the power of negative 9 moles per liter, that's a concentration. Traditional significant digit rules apply to that, which means it has 3 significant digits. Down here I have the pH, which I also want to express now with 3 significant digits, but that means 3 decimal places. So I have 5.193. A worthwhile thing to do when you encounter a calculation question is just check to see if there's a match. pH, OH, that's not a match. That means we have this extra conversion somewhere. This conversion from pH to pOH, it's either going to happen as our first step or the last step in our work. Really pay attention to your units. Sometimes we're going to have units and other times not. When we're solving for the pH or the pOH, we're not going to have units. But when we're solving for concentration, yes, there will be units. Also, really be conscious of what's going on with your significant digits because it's very easy to make a mistake. And I hope that helps.